Ladies and gentlemen, fans and aficionados of calculus, welcome. Today we're going to go over how to find the area of a region between two curves. We've had a homework assignment handed out earlier this week, these problems 1 through 7. In this video lesson I'm going to go over problems 2, 4, and 6. Here are the instructions. For each problem, sketch the region bounded by the graphs of the functions and find the region of the area. So we're going to go straight to problem 2. And here it is. We have two functions, y equals x squared minus 4x plus 3 and y equals negative x squared plus 2x plus 3. So we're going to graph both of these functions, just have a sketch of what's happening. Excellent step. So we have x, y, and we're going to label these two functions accordingly. This one on top here is going to be called g of x, and the one on bottom we're going to call f of x. And let's just go ahead and analyze this top function first. We have, first of all, for this top one, we have our y-intercept is going to be the coordinate pair 0, 3, because that's what's indicated. And then if we set this x squared minus 4x plus 3 equal to 0, what we have is, working to the right here, 0 is going to be equal to quantity x minus 1 times quantity x minus 3. And so our zeros are going to be x is equal to 1 and x is equal to 3. And so now we have a y-intercept at 3, we have a x-intercept at 1, and another x-intercept at 3, and so we can sketch in what this g of x function looks like. So we're going to be something like this. There we go, upward opening parabola. So next we're going to set these two functions equal to each other, and in so doing what we have is we have x squared minus 4x plus 3. We set that equal to negative x squared plus 2x plus 3. And now we're going to get all everything on one side. Now we have 3 and 3 on both sides. We can cross those out. So on the right side we're going to add x squared and subtract 2x. And because we did that on the right side, we're going to need to do that on the left side of the equation. So we have plus x squared here and minus 2x. So on the left side we're left with 2x squared minus 6x. That's equal to 0. And solving by factoring, our common factor here is going to be 2x, and 2x times quantity x minus 3 is equal to 0. So we have x is equal to 0 and x is equal to 3. So what that's going to do, that's going to determine where our intersection points are. So I'm going to we're going to have intersection point here at x equals 0, so that's going to be at the y-intercept. So the curve is going to look something like this. Yeah, a little bit of a shaky hand, but the area we're talking about is this green area between these two curves. Okay, so let's go ahead and set up what the calculus of this looks like. Well, what we're going to have is, getting a pen I like. Here we go. The integral is going to be, let me show you in a basic format what it's going to be. The area between two curves is going to be the integral from the bounds of integration, we'll say a to b, of a certain function which we'll call f of x minus g of x. dx. And what this is going to be for us is, in this instance, we're going to have, we know our bounds or limits of integration are 0 to 3, and we know our f of x is going to be this top function here, which is going to be negative x squared plus 2x plus 3, and we're going to subtract from that our g of x, which is going to be x squared minus 4x plus 3, and that's going to be dx. And then simplifying, we have 3 minus 3, and left over, if we simplify things, again we're going from 0 to 3, we have negative x squared minus x squared, so that's going to be negative 2x squared, and then we're going to have 2x minus negative 4x, which is going to end up being plus 6x, and that's going to be dx. And here has a blank what the integral is. Well, that's going to be this right here. That's what it is. And just working down, we're going to integrate now, and the integral of negative 2x squared dx is going to be negative 2x cubed over 3. And then we're going to have plus 6x squared over 2. And we're going to integrate this. We've integrated all the way from 0 to 3. And so what that's going to do is this 6 over 2 is 3, so just working to the right, we're going to plug in 3. So we have negative 2 over 3. In the place of x we have 3, and we're going to cube that, and then we're going to have plus 6 over 2, which is 3, and it's going to be x squared, which is 3 squared. And so now just concluding below here, we're going to have 3 cubed, which is 27 divided by 3, which is 9, and 9 times negative 2 is negative 18. And then we have 3 times 3 squared is plus 27. So our answer is going to be 9. And so we put 9 over here in the area. So let's go ahead to the next problem we're going to look at is 4. We have the two functions we're given here this time are y equals quantity x minus 1 cubed and y equals x minus 1. So what are these? We're going to sketch these functions here. So we have our xy coordinate plane like this. And what we have here for this quantity x squared, quantity x minus 1 cubed is really the parent cubic function, which is x cubed, but shifted 1 unit to the right. And so what we're going to do, the shifting of it is going to make it look something like this. So that's what that function looks like. And then, so that's going to be our quantity x minus 1 cubed. And then this next one here, this y equals x minus 1, what we're going to do is we're going to draw a line. So there it is. This is our y equals x minus 1, and so the area between the curves is going to be this area here I've shaded in green, and then this other area above the curve. And it's not readily apparent, but because of symmetry, these two areas, doesn't look like here, but they're going to be the same area. And so what we have here is, let's go ahead and look for our intersection points to get our bounds of integration. So what we're going to do is take our quantity x minus 1 cubed and set that equal to x minus 1. And then if we plug in 0 for x, we are going to get negative 1 cubed on the left side, and then 0 minus 1 on the right side. We'll have negative 1 equals negative 1. So x equals negative 1 is one of our points of intersection. Similarly, if we plug in 0, we're going to get, if we plug in 1, we're going to get 1 minus 1 on the left side, which is 0 cubed, and 1 minus 1 on the right side, which is 0. So we're going to have x is equal to 0. And finally, if we plug in 1, or we plug in 2, we're going to get 2 minus 1, which is 1 cubed, which is 1. And on the right side, we have 2 minus 1. So we're going to have x is equal to 1. So these are the 3 zeros that we have, or the 3 points of intersection. And so setting up this integral, what we're going to have is, we're going to have an integral of these different pieces. Well, the first one we're going to have is from negative 1 to 0, and for this first piece, the function on top is the cubed function, so that's going to be this quantity x minus 1 cubed, and we're going to subtract out this x minus 1, and that's going to be dx, and then we're going to add this next piece, which is from 1 to 2 of, now we're taking a different order now. We're taking this x minus 1 and subtracting from it this quantity x minus 1 cubed, and we're going to say dx. And so this is going to be our whole integral. Now, because these areas are the same, and what we can do is we can just simplify our work and not have to do both of these integrals, because we can multiply either of these integrals by 2 and accomplish the job. So all this here is going to be equal to 2 times the integral from 1 to 2 of this quantity x minus 1 minus quantity x minus 1, okay, x minus 1 minus quantity x minus 1 cubed, and it's going to be dx. Now what we're going to do is do a U-substitution, and for that we're going to let u equal x minus 1. So therefore, we're going to have du is going to be equal to dx. And writing this with our U-substitution, we're going to have 2 again. Now for our limits of integration, if we're going here from x equals 1 to x equals 2, well, if x is, let me see, if we let x equal 1, u is going to be 1 minus 1, or 0, so u substituting, our limit is going to change to 0. If we let x equal 2, u is going to be 2 minus 1, or 1. Okay, so that's pretty neat. And so now what we have is, we have u replacing this x minus 1 minus u cubed, which replaced this quantity x minus 1 cubed. And we're going to have du, because du is equal to dx. And so that's going to be it. So just we're just going to go ahead and work to the right here and integrate. So we're going to have 2 times everything, and the integral of u du is going to be u squared over 2, and we're going to have minus the integral of u cubed is going to be u to the 4th power over 4. And we're going to evaluate all this from our new limits of integration from 0 to 1. And just working down here, we're going to replace, okay, we're going to have that 2. We're going to bring this 2 down here. And if we replace this u with u squared, we're going to have 1/2 minus 1/4, which equals 1/4. And so we have 2 times 1/4, or 1/2. So each of these areas in green, each one of those 2 is 1/2. So this is going to be our basic integral, and our answer here is going to be, our area is going to be 1/2. So that is problem 4 worked out. And finally we get to problem 6. We have y equals the square root of 3x, then plus 1. So that's one of our equations. And let me go ahead and make the sketch of it here. So we have our xy coordinate plane again. And what we're going to have is this quantity, this square root of quantity 3x plus 1. We're going to start here at our y-intercept of 1. And we're going to have a square root curve. It's going to be kind of like the parent square root function, except it's going to be stretched by a factor of the square root of 3. And then we have this second function, and that's going to be this one right here. I'm going to go ahead and arrow to it. And the next one we have is this y equals x. So we have this diagonal just right here. This is our y equals x in purple. So there it is. That's the purple one right here. And then we are bounded by x equals 0, which is this left edge right here along the y-axis. And so we're talking about this area right here. Okay, let's go ahead and we're going to find our limits of integration. Well, we know we're going to have our area is going to be equal to the integral from 0 to, well, we don't know where yet, but then we're going to have our top function is going to be this square root of 3x. Let me go ahead and make our pen a little smaller. Here we go. We're going to have our square root of 3x plus 1. So this is going to be our f of x function, and we're going to subtract out our g of x function, which is x, and we are going to dx. Now we need to find this intersection point here, that purple arrow, and actually what I meant to do for that is not arrow to the intersection point, but rather to the line itself. There, it looks a little better. Okay, so what is going to be the x value of that intersection point? Well, we know it's going to be the y value too. So let's go ahead and set these two equations equal to each other, and we have square root of 3x plus 1 is equal to x, and then we subtract 1, so we get square root of 3x equals, meant to subtract 1. Okay, subtract 1. There we go. So we have x minus 1 on the right side. If we square both sides, we get 3x is equal to x squared minus 2x plus 1. And if we subtract 3x from both sides of the equation, we get 0 is equal to x squared minus 5x plus 1. And this is not a factorable function or equation. So we're going to have to use our quadratic formula. For this, we're going to have a is equal to 1, b is equal to -5, and c is equal to 1. And so we're going to have x is equal to, we have negative b, so -5 is 5, plus or minus, we have square root of negative b squared, well that's going to be 25, minus 4ac is going to be minus 4 over 2. So we're going to have is x is equal to 5/2 plus square root of 21 over 2, and we're going to have x is equal to 5/2 minus square root of 21 over 2. And what happens is this 5/2 plus square root of 21 over 2 is going to be approximately equal to 4.7913, I think. Let's get that in the calculator. 4.7913 about. Okay. So we have, so that's going to be that. So that means that we can go ahead and put in our value up here, which is, we can put 4.7913. Now what we could do, at this point we had to use a calculator already to get this decimalized version. What I'm going to do is I am just going to, and I hope you had a calculator at hand to do these exercises because there are a lot of opportunities to make mistakes. And so what I'm going to do is I'm just going to enter this integral in the calculator, and we're going to have our answer right here. So our integral is going to be right here. And let's go ahead in our calculator. So we're going to have the integral, which we get from Math 9. We're going to go from 0 to 5, which is 2.5, plus, let's see, square root of 21 over 2. Now, one thing I didn't tell you about was that 5 over 2 minus square root of 21 over 2, well, that's going to end up being 0.2 something, and that's what's called an extraneous solution. So we go ahead and look at this, and we're going to have square root of 3x. I'm going to put second of 3x, and it's going to be plus 1, and we're going to subtract x, which is going to be what our g of x is, and it's going to be dx. And for this we get to 3 decimal places 5.423. 4.523. And I'm going to go ahead and just 5.423. I'll put it like this: 5.423. That's going to be our answer. Go right here. And in case you're interested, there's another way of doing this too, which I did earlier before recording this video lesson, and just making a U-substitution for u equals 3x. And here is the same thing with that U-substitution here on the right side. So if that's of interest to you, go ahead and look at that. And again, our area is 5.423. This has been really interesting, and even for me, kind of challenging working out these problems. I hope this has been helpful to you. I just advise you to have a calculator at hand to check your work. That calculator is come in handy for me a lot doing these exercises. Good luck, and thanks for viewing.